additional videos or practice problems to try out these skills. So let's go ahead and get started with our do now. Go ahead, pause the video, and take a few minutes to divide out the following 3 equations. Alright, so for each of the equations, you should have gotten 4 as your solution. And if you notice, since they're all 3 the same, we talked about this yesterday, but if these represented some sort of relationship and their ratios are all the same, then we call this a proportional relationship. And this 4 that we've gotten is what we call our constant of proportionality. And so today we're going to be working more with that constant of proportionality in some different problems in context. So let's go ahead and look at a problem and talk more about this. You're working on math homework and you decide to time yourself. You notice you are able to solve 4 problems in 24 minutes. Now, you may remember from yesterday, we looked a lot at this k equals y over x equation. We used that all the time when we were figuring out whether the ratios in our tables were the same or not. We briefly looked at this other equation, y equals k times x. Now, I want you to notice that these 2 equations represent the same thing. In both cases, k is our constant of proportionality. So we're going to use this and look at this problem and see how this helps us. So we're actually going to put a name to our y and our x. So our y is what we're going to call our dependent variable. That means our y value depends on something else. So if we look at this problem that we have here, you notice you are able to solve 4 problems in 24 minutes. Now, we're going to assume that you're working at a constant rate. And so the amount of time you spend on your homework is going to depend on the number of problems that you're working. So our 24 minutes is going to be our dependent variable in this problem. Now our x is what we call our independent variable. So in this problem, our independent variable is the number of problems that we're working. Now, this may seem a little confusing because you may think, well, maybe I work some problems faster than the other, or maybe I have more problems of homework that are difficult one night and some problems that are easier another night. Well, in this case, we're thinking about working at a constant rate. So we're saying we're going to work each problem the same amount of time. So we can't control the number of problems that we have to work on, but that number of problems does impact how much time it takes us to work. All right, so now I've gone in and added our question that we're actually trying to figure out. So we're trying to figure out how many minutes it takes us to work each problem. Well, if we're looking for minutes per problem, that means we're going to want to take the number of minutes we spend working and divide it by the number of problems we have. So if I take 24 and divide it by 4, well, then that's going to tell me that it takes me 6 minutes per problem. Another way you might want to think about this is by drawing out a tape diagram. So if I draw out a tape diagram, and I say this entire thing represents the 24 minutes that I spend working, and I've worked 4 problems, well, I need to figure out what chunk of this time that I've spent is going to go with each problem. So if I take 24 and divide it up into 4 different boxes, that's going to give me 6 minutes in each box, where each box represents 1 problem that I've worked. So again, we get 6 minutes per problem. So we've looked at one example of our constant of proportionality and how we can find that. So we found 4 minutes per problem. Some other examples of proportional relationships: 50 miles per hour, 3 teaspoons per tablespoon. Now, what do you notice about each of these denominators? Well, hopefully you see that each of these is per 1. So per 1 problem, per 1 hour, per 1 tablespoon. And if you remember, per 1 means that K is our unit rate. So anytime we're finding something per 1, we're actually finding the unit rate. So in summary, when determining the unit rate, first we want to decide what relationship we're looking for. So if we think back to our example that we did, were we looking for finding minutes per problem or problems per minute? That makes a difference in how we solve for our unit rate. We want to write this as a fraction to help you see which value is your dependent variable, or your y value, and which one's your independent variable, or your x value. And then lastly, we just want to divide y by x to get our unit rate. Alright, so go ahead and pause the video here. You've got a couple of practice problems to work on. Take a few minutes to do that, and then we'll come back and go over the answers. So on number 1, you should have gotten 60 miles per hour. And on number 2, you should have gotten $1.59 per pound. Now, if you feel confident with these, you're ready to move on to some independent practice, go ahead and skip to the end of this video to get your Khan Academy assignment. If you're not so sure about one or both of these and you want to see them marked out, just keep watching where you're at. Okay, so on number 1, it tells us that Gio's family drove 420 miles in 7 hours. And our goal is to figure out how many miles per hour did Gio's family drive. So I want to remember that to find my unit rate, which is what I'm looking for, I want to take y and divide it by x. Well, in order to do that, I've got to figure out what my y value and my x value are represented by in this problem. So if we go back through and reread our question, we're looking for how many miles per hour. So miles is going to go in my numerator. Per hour is going to go in my denominator. Well, I already know that Gio's family drove 420 miles in 7 hours. So I can take these two things and divide them. And when I divide 420 miles by 7 hours, I get that they drive 60 miles per hour. Another way you might have done this is using our tape diagram. So if we draw out our tape diagram, we want to let the entire thing represent whatever is in my numerator. So in this case, miles is in my numerator, so my entire tape diagram is going to represent 420 miles. And I'm going to divide it into however many pieces are in my denominator, which in this case is 7. So when I divide 420 miles up into 7 different pieces, I get 60 miles in each of these pieces. And we know from the context of our problem that each piece represents an hour. So number 2 says, Amber went to the store and bought 5 pounds of chicken for $7.95. And we want to know what is the cost per pound of the chicken. Again, we're going to be using this equation, k equals y divided by x, but we've got to figure out what our y and our x value are represented by in this problem. So in our question, it tells us we're looking for the cost per pound. So the cost is going to be what goes in my numerator, and pounds are going to be what go in my denominator. So I see in my problem, I have 5 pounds of chicken, and it cost $7.95. So I want to take $7.95 and divide it by the number of pounds of chicken I have, which is 5. When I do that, I get $1.59 per pound of chicken. Alright, so if you go log into Khan Academy, you should see some practice labeled rates with fractions. Of course, if you have any questions, feel free to reach out to me. I'll probably be just hanging out with our new kitty. Her name is Pina, so you'll probably see some pictures of her in some of these videos from now on. Feel free to reach out to me. Remember, we'll also have another Hangout meeting this week, so you can also ask questions then. The videos are included in Khan Academy, so if you want to watch some of those as well to get a little extra help, you're welcome to do that. Thank you guys for watching.